Hi students, in this video I'll be going through the 2022 A Math paper 1 question 1. Right, so let's start by reading the question. Right, the equation of a curve is y equals to 2x squared minus 8x plus 11. Right, by expressing 2x squared minus 8x plus 11 in the form of a times x plus b squared plus c, where a, b, and c are constants, okay, find the coordinates of the stationary point of the curve. Okay, so for this question, what they want you to do is to complete the square and express the quadratic expression in the form of the completing the square form, right? Okay, so that's basically what we are going to do, right? So let's start. So y is equals to 2x squared minus 8x plus 11. Right, so to complete the square, we always need to factorize out the coefficient of x squared. Okay, so we will get this. So x squared minus 4x plus 11 over 2. All right. Okay, then we will do completing the square for the term inside the bracket. Right, so to complete the square, we need to add half of this value. So if this is minus 4, we will add half of it, the square of half of that, the coefficient of x. Okay, then since we have added something, that means we have altered the expression, right? The value of the expression, we need to subtract it away. Okay, so we will get this. Okay, so why do we want to do this? Because these three terms will then factorize to x minus 2 squared. Okay, so x from here, then minus 2 squared. So if you expand out this x minus 2 squared, you will get back this x squared minus 4x plus negative 2 squared, all right? Okay, then we just compute this whole thing out. You should be able to get 3 over 2, right? Okay, so negative 2 squared is 4, right? So you have minus 4 plus 11 over 2. 4 is 8 over 2. So 11 over 2 minus 8 over 2, you get 3 over 2. Okay, then we need to multiply this 2 back into the bracket. So you get this. Okay, then 2 times 3 over 2, you will get plus 3. Right, so we have successfully expressed in the form of a times x plus b squared plus c. So in this case, a is 2, b is negative 2, and then c will be 3. Okay, so this is the first part of the question. Okay, so how can we identify the stationary point? Okay, so if you look at the value of a over here, okay, so a is 2, right? Okay, if a is positive, that means the curve is a smiley face, so it has a minimum point. Okay, so when will this particular expression have a minimum point is when this thing is equals to 0, x minus 2 is 0. Because when because there is the smallest possible value that you can get for x minus 2 squared. Okay, so for what value of x will we get x minus 2 squared equals 0? So it's very easy to tell. You can just set x minus 2 to 0, then x will be equals to 2. Okay, that means the x coordinate of the stationary point is 2. And then when x is 2, right, this whole thing becomes 0. This whole thing becomes 0, right? Okay, then the y value will be 3. Okay, so that means coordinates of stationary point will be equals to 2 and 3. Right, so the advantage of the expressing a quadratic expression, right, okay, in the form of the completing the square form, so you can tell the coordinates of the stationary points very easily. Right, so actually I've plotted it out in decimal, so we can actually go over and take a look. Right, so this is the graph 2x squared minus 8x plus 11. So as you can see over here, it's a minimum point curve, and the coordinates of the minimum point is 2, 3. Okay, just as what we have obtained, right? Okay, let's go to take a look at part B of the question. Okay, so the line y equals to 2x plus 3 intersects the curve at the points A and B. Okay, find the value of k for which the distance AB can be expressed as square root k. Okay, so basically when the line intersects the curve at 2 points, right? Okay, if it intersects at 2 points, that means to find the coordinates of those 2 points, the moment you hear intersect, right? Okay, you'll think of solving the equations simultaneously. Right, so the equation of the curve is this. Okay, so it's related to part A. Okay, it's the same curve. Okay, so this 1, and then the equation of the line is this. So this 2, right? Okay, so we're going to solve these two simultaneously. So equate 1 and 2. Okay, so we'll get 2x squared minus 8x plus 11, 2x plus 3. Okay, so bring over. Okay, so before you factorize, we ask yourself, always ask yourself whether you can simplify the expression or not. So indeed, in this case, we can divide by 2, all right? Okay, so always make the number smaller first before you factorize. Okay, so this one can be factorized very easily. So it will be -1 minus 4, right? So it's either x minus 1 is equal to 0, so x will be 1, or x minus 4 is 0, so x will be equals to 4, right? So we will sub into 2 to find y, okay? So y will be equals to 2 times x is now 1 plus 3, so 1, 5. Okay, then for here y will be equals to 2 times 4 plus 3, so you will get 11. Okay. Okay, so they never tell they didn't indicate which one is A and B, so you can just assign lah. Okay, so we assign the first point to be A, so A will be 1, 5. Okay, so this will be one answer, and B will be equals to 4, 11. Right? Okay, so now we're going to we need to find the distance between the 2 points, and then we should be able to express it in the form of a square root k. Okay, then we can determine the value of k. Right? So the distance AB. Okay, so if you recall the formula, okay, for the distance between 2 points, we can use x2 minus x1 square plus y2 minus y1 square. Okay, where okay, we can assign A, this one to be x1, y1, and this one to be x2, y2, right? Okay, so x2 minus x1 square, so 4 minus 1 square plus 11 minus 5 square. Okay. Okay, so down here we will get 4 minus 1 square, 3 square is 9. 11 minus 5 square, 6 square is 36. So we will get square root 45. Okay, so they say that this one, the distance AB can be expressed as square root k, right? Okay, therefore k has to be 45. Right, okay, so this is how you do a question like this. So it's I would say a rather simple question, okay, related to quadratic equations and functions, right? Okay, so we can actually plot it out. Okay, why not we plot it out? We add in this line 2x plus 3, and then we see whether the intersection point is 1, 5, and 4, 11. Okay, so let's go back to decimals. Y equals to 2x plus 3. We add in one more point, y equals to 2x plus 3. Okay, so you can see here 1, 5, and then the other one is the 4, 11. Right? Okay, so whenever you want to find the intersection point between any line and curve, or curve and curve, or line and line, you always solve the two equations simultaneously.